Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, the last video, got the output tubes all dialed in, got the amp powered up, power supply's working, the output tubes are happy. So in this video, we're ready to do the wiring on the input tube, get the RCA jacks hooked up to the grids of these tubes, get them all biased up, and then check all the voltages and make sure that all of that's good and that it's then ready to test with the Analog Discovery 2. And so I'm excited. We're getting real close to the end of this kind of first segment of the build. And I know I'm not showing like a super detailed, like, here's where I'm soldering this wire and here's where I'm soldering that wire. And I'm just kind of showing you, okay, here's where I've hooked this stuff up. Before we get to the point where we're like actually releasing a kit version of this, I'm going to do a super detailed video series that is basically going to be an unboxing of the kit like you would get it, and then just step by step how you put everything together in a very detailed manner so that you can assemble one of these. And I really hope that between now and then, if you're interested in building one of these, that you spend some time and learn how to read a schematic. I mean, I really feel it's almost like somebody trying to learn to play the guitar, but they don't want to learn how to read music. And I really want this to be a learning experience and an enjoyment of the hobby, not just, well, I want to save some money building it myself, and that's why I want a kit. Because you're going to have a problem. In the future, there could be a capacitor goes bad, or solder joint while you're putting it together is not connected good. And then you're going to be on the phone to me or be emailing me wanting me to diagnose what's wrong so you cannot learn how to read a schematic. And that's my big fear with the kits, is that people are going to want to buy them without understanding like what is actually going on, or be able to look at the schematic and say, okay, yeah, this capacitor and resistor needs to be hooked to this point because here it is in the schematic. You're not going to understand what you're doing. And that's just going to lead to problems for you and for me. So, again, if you're interested in this and really think you might want to build the kit when I decide to release them later this year, start learning now how to read a schematic and be able to follow, how wires are run, looking at that. It's not rocket science. So anyway, let's get to wiring up this input tube, check all the voltages, get that all biased up right. Hopefully by the end of the video, this thing will all be powered up. Everything will be where we want it to be, and then we can move on in the next video to testing it on the Analog Discovery 2. So let's get busy wiring up this amp. Okay, so let me show you how I'm going to lay this stuff out. Over here, we're temporarily connecting this stuff to get the grid grounded, and I wasn't even planning on putting this grid stopper in back then, but anyway, and part of this process is looking at this, and it's probably going to get taken apart and put back together several times, or prototypes are going to get built differently as I go through these processes of sorting out which output transformers I want to use, and the builds are just going to get better and cleaner as I do more of them. So anyway, going to move this resistor and put it from here to here just to clean up that so it's cleaner looking there. Some people say you got to have just the grid stopper hooked to the grid. I'm not convinced that's the case, but it's easy enough to just hook it from here to here and it's cleaner looking anyway, so we're going to do that. So then this will be where the grid connection for the output tube comes. So let's look at how we're going to power up the input tube. Going to bring a power wire from here to this terminal, and then do another one from here to here. So this and this is going to be our full voltage. Then we're going to have the input tube dropping resistor from here to here. I think it's a 4.7K from here to here. And then we're going to have the decoupling capacitor is going to connect from here to here, from here to here, because this is our ground. So then this will be our decoupled DC for the plate voltage. So we'll run a plate load resistor from here to here, and from here to here. And then this will just be a piece of wire that runs across here over to this pin. And same thing here, there'll just be a piece of wire that runs from here to this plate. And this will also be the plate connection on the other side of the plate load resistor that we can hook our shade feedback resistor, which will go from here to the plate, and from here to the plate and the output tubes. So then this is going to be where the cathode LED connects from here to here, then from here to here. This is going to be ground, this is going to be ground, these two right here. So then we'll put our 160 ohm resistor from one side of the LED to ground on both of these. Then we'll put our grid stopper from here to here, then from here to here. Then we'll put the 1 meg grid leak resistor from here to ground, from here to ground. And if we're not going to use a potentiometer, that'll probably be more like a 240K resistor from here to here. So this will be where our input signal hooks up, and this will be the ground for the input signal, here and here. And I haven't really decided exactly how the final grounding is going to be. I don't like this big long wire across here. But I don't know, I got to figure something out better. I'm thinking about possibly using one of these terminals as a ground, just having a single power connector and have one of these a ground and run a big fat ground wire from there down to here. Then I could ground this cap here and possibly ground the front end over here as well. But I got to think that through and make sure that we're not going to be creating some kind of ground loop or running the front end ground through this capacitor ground that might pick up some noise. I have to think that through. Again, part of this is just to get this amp built, get it all biased up, and go listen to it. And get the tuning of whatever we got to do to get this amp sounding good. And then in the next version, work out some details about, you know, the hardware we're going to use, and maybe where some of the grounding is going to be done in a simpler manner, and clean up some of the layout of the wiring. But I feel like this is going to work really well for wiring up this input tube and getting the plate voltage for the input tube decoupled from the main power supply over here. Clean this up. Oh, and then the coupling cap will just go from this terminal over to this terminal. Nice and simple. And that way, I actually might even hook this grid leak resistor down in this lower hole. So the nice thing about that is the coupling cap's going to be connected from here to here, and if somebody really does want to put some kind of alternate coupling cap in there, so they want to put some MyFlexes or some of that kind of thing, there's a ton of room right here to have like some giant coupling cap, because I know some of them are, they're big. So I want to leave some room for that option for people, and it also will make it easy to do because the coupling cap is just soldered to, individual tag strips. So anyway, I'm going to get started wiring all of this up off camera. And again, once we get this all sorted out, I'm going to do a very step-by-step build video. But guys, this is a prototype. I'm not going to do a step-by-step build video on something that's, 15, 20 videos that is just the prototype, and we have to do another set of them. So anyway, let me get this wired up, and I'll show you what this looks like once I get all this stuff done. Okay, do a quick close-up of the 9-pin input tube wired up to these tag strips. So one side of the heaters go to pins 4 and 5. The other side of the heater goes to pin 9. Pin 8 is the cathode. So you have the positive side of the LED connected here, the negative here. And you want to leave a little slack in these leads because these pins wiggle around a little bit. You don't want to like pull the leads out of this LED by having it like taut across here. You want to, like I said, make a little kind of a bow of it. Then here is our grid stopper. You can see the resistor, this 1.2K. It's up close to the tube socket. Then we have a little PTFE tubing here. Got it connected down to this terminal. And then we have the plate. It's just this yellow wire that comes across to here. Then on the other triode, here's the plate with the yellow wire. Here's the cathode with the LED going from here to here. Again, after you solder them in, you want to get your digital multimeter, set it on diode check. Put the positive here, the negative here, and you can see the little LED light up. You know you've got it the right direction. And then finally, this is the grid stopper for the other triode. It comes over to this tube. So the grids are hooked here and here. Plates are here and here. Cathodes here and here. And let me wire up some more of this stuff and I'll show you what we did there. Okay, let me show you what I got wired up now. So we have our grid stopper that goes from the grid over to this terminal here. Then we have our grid leak resistor that I decided to go ahead and install in these lower holes. So this is a 1.2K, this is a 510K, goes from here to ground. Again, this is run up to the ground up at the cathode of the output tube. Then again over here, we've got the same thing. We've got a grid stopper. We've got a grid leak resistor down here. Okay, this red wire is the power wire that's coming over here from our capacitor and our B plus power supply. So it comes up here, connects to this terminal and this terminal. Got a 4.7K dropping resistor, goes from here to here. And this is our filter decoupling capacitor. It's going from the other side of this resistor, it's a dropping resistor, and ground. So back behind here, this is our plate load resistor. There's one there. Got another one here. Goes to this terminal and this terminal. So that's on the other side of the plate load resistor. So that's where we're pulling the signal off of the input tube with this coupling cap. And it comes across to this terminal here. And then there's another one that's back behind this cap. But it goes from here over to the grid of the output tube. So, like I showed you in the earlier segment, this goes to the plate, that goes to the plate. There's the cathode. Here's our 160 ohm resistor that comes to ground. And then here's our grid stopper on the input tube. And then down here, I've got a little 1 meg resistor. If you're going to wire it up without a volume control, probably put something like a 240K here. That'll set the input impedance of the amp. But since we have a volume control, where I'm going to wire a volume control into this one for myself, it's got 100K across it. And so that provides the extra resistance. This 1 meg's here to ensure that even if the volume control wiper goes bad, that we've always got a grid to ground reference. So same thing here, 1 meg. This is our 160 ohm that hooks up to the LED that goes to the cathode. And again, this goes from here to the cathode, the tube. And all we've got left to do now is I need to get ground from here to here. And then I'm going to run this. And I'm actually going to try just running it over here to this ground on this cap. And I'm hoping that that's going to be a nice clean ground. And then it comes up with this big long wire up here to our star ground point that's up here in the front of the amp. Here's our star ground point. If I have to, I can run a ground wire from the front end all the way up here. But I'm hoping that this will be a clean enough ground signal here so that the next amp I'm going to assign one of these two terminals, because I don't need two B plus terminals. Probably going to assign this one to be a ground and run a big fat ground wire up to our start ground point, and then I can ground this cap and then ground the front end over here at this ground point. And again, it's not connected to the chassis, it's just collecting some grounds. So let me go ahead and hook this ground up from here over to here, to get this stuff grounded. And I want to show you that before I put these other wires in. It might hide some of this. Put these grounds on, and then we'll be ready to power up the input tube and check the bias and the plate voltage. One of the things too I wanted to clear up, if you watch the video when I was drawing load lines, I showed a schematic and it had the plate voltages. Well, what I didn't explain is there was an extra DC source coming from the shade feedback resistor, and that's why the voltage in the schematic didn't match the load line chart. But before we put the shade feedback resistor in, I want to power this amp up and see what the voltage drop across this plate load resistor is, and make sure that it's what I'm expecting it to be looking at the plate curves. And then we'll add the shade feedback resistor and the volume control and go listen to this thing. So let me get this ground wire in and we'll be ready to power this thing up. Okay, well, we're going to come in here and check our voltages on the front end tube and recheck the voltages on the plate, the output tubes. The voltages may have come down a little bit, that we've added the current from this stuff all being online now. So let's check that out. And again, I'm going to show you why I use rectifier tubes rather than using diodes. So watch the voltage. We're going to do this in real time. I'm not going to edit the video here. And yes, the amp's powered on. Output tubes, heaters are getting nice and toasty. And here comes our voltage. The nice thing about using a 5AR4 is it gives the output tube heaters and the input tube as well a head start. And so they can start getting the cathodes warmed up before the voltage comes onto the plates. And a couple of good things about that: it helps the capacitors because we don't see huge voltage spikes, and it also helps the inrush current because it slowly fills the caps, and it also lets the output tubes get warmed up before it hits them with high voltage. So got 437 volts on the rectifier tube output. We'll come over here, got 430 at the output filter cap. So let's check our plates and screens here. Got 422, got 418, a few volts less than the plate, which is what I like to see on a pentode. That's why we use this 1.2K screen stopper to drop the voltage just a breath on the screen so that the tube operates the way it was designed. And got 31 volts on the cathode, 422, 418, just a breath lower, and a little over 30 volts on that cathode. That should give us around 60 milliamps on the cathode. We're going to have about 6 milliamps on the screen for measuring the voltage drop across this resistor in the last video. So that gives us about 54 milliamps on the plate. And then you subtract this voltage from this voltage, and that gives you voltage across the tube. And we'll do all those calculations in the next video, and I'll go over my little online calculator I like using that makes this really simple, and show you the plate dissipation, which is probably going to be close to 88 to 90%, which is what I like seeing on a single-ended amp. So you can see our LEDs are lit up. That shows you that current's flowing through the tube. We're going to check our voltage here. We got 430 volts, and that's the voltage that's coming off of the positive side of this cap to the main power supply feed. So we got a 4.7K drop-in resistor, which gives us 427. And then the plate voltage is 215, which is half of what we see here, which I've kind of found is a good place for a triode to be biased. So then over here, got 427, and on the plate, again, we got 215 or 214, and then we're going to check our bias point, got 1.75 volts, and then on the other cathode, we've got 1.75 volts. So all those voltages are exactly what we want to see. Now, this is a shade feedback amp, which means we're going to be connecting this plate connection to this plate connection. And in doing so, that adds some voltage to this plate reading, which will make it obviously different than what we saw on our triode curves chart, but that's fine. That's just part of how shade feedback works. So all I've got left to do now at this point is install the shade feedback resistor from this plate to here, from that plate to here. Then install the volume control and the RCA jacks. I've shown y'all how to do that on other amps, so I'm not going to go into detail at this point in this build showing you how to do that. And then we'll be ready to put this thing on the audio analyzer suite, run it through its paces, and then go give it a listen. And I think this is a great place to end this video. Well, I'm happy to see everything turned out just like I was expecting. And if you haven't seen the video that I did on tube curves and joining a load line, go watch that video. And the only thing that kind of throws a wrench in that works, and I showed you in this video about that, is you're going to have one plate voltage on the driver tube without the shade feedback connected, but then when you connect the shade feedback resistor, you're going to get some voltage off the plate of the output tube, which is going to raise that voltage up from what you would expect to see from looking at the load line. And I hope that makes sense. And I know this whole shade feedback thing is kind of a controversial topic. I think it sounds awesome with an ultralinear amp. And hey, that's just going to be one of the kind of signature things that we do on Skunky Design amps, especially with ultralinear pentodes. We're going to be using shade feedback in them. And so it's important to understand, at least from a technical standpoint, about how that affects the plate voltage that you see on the driver tube and why it's a little higher than it would normally be if you were using the, cathode-based global negative feedback like a lot of amps use. So anyway, I think this thing's good to go now. And I'm ready to hook it up to the Analog Discovery 2 in the next video, run some sweeps on it, make sure that everything looks like we hope it will, see what kind of actual power levels this thing makes, make sure the driver tube's able to drive these output tubes, which I'm sure it is, and then I'll do some listening to it, and we'll finish up that video with like a, hey, here's what it sounds like. And then, again, we're going to be building another one of these, identical to this, with musical power supply output transformers, and then going to be building another one with the Thermionic Labs output transformers. And then we actually may be building a fourth one using some ISO Tango 12-watt units and see what that does. And then by that point, we'll definitely have like a selection of different things that I can choose from and let you guys know, like, hey, this really sounds good, or this is whatever. And then at the end of all this, I'm going to be selling off these prototypes more likely, and I may keep this very first one as the 001 OG one just to, hey, just keep around, you know what I'm saying? Who knows, in the future might have a retail store somewhere and I can put this in the window and say, here's where it all started, kind of a thing. So anyway, hope you enjoyed this video. If you did, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters, donators to the website, all you folks that have sent me emails saying, yes, I'm interested. Where do I pre-order? That's coming up soon. I just want to get some actual products that I could sell and be able to give you guys options on which one, hey, which one of these do you want, and that sort of thing. And before I take a bunch of pre-orders, I need to get this chassis fab thing kind of figured out, which I'm still working on. So anyway, till the next video, have a nice day.